Hello, my name is Tawny J. Tack, and this is my final project for CS2 Intro to C++, course code 10139. Now here is the beautiful window thanks to Simple and Fast Multimedia Library, SFML, with my title at the top here, this black screen or black window background, and some green live cells. Now on the sidebar panel, we have the number of live cells currently is 50 because initially I chose to initialize this grid to have 50 random cells rather than just a clear state. And the generation number is here currently 0 because the user has not chosen to step at all. Then the file name would be here, currently is none. This is also manually input by the user, which I will showcase in just a moment. And here's the main menu to guide the user through which keyboard inputs will spark certain functions to manipulate this world of cells. Now, to showcase these cool commands, I'm going to clear and I'm going to randomize. Generation is still 0, but the live cell count is going up by 50 each time, incrementing by 50 each time. And then we can go and see some interesting patterns. So this go runs for 10 generations and live cells continue to change, but the generation number continues to increment by 10. And now to save a file, the user has to write vfilename.txt or whatever file name they choose. And then we can see that clear evidence that this works by typing in L filename.txt, by clearing the state, then typing in L filename.txt, and then we see that world from before we cleared the state. Some challenges I faced while writing this program were implementing the count neighbors function and also figuring out how to make Go only run 10 generations rather than for every frame rate until this window is closed. So how I fixed those problems, starting with count neighbors. I initially was trying to use nested for loops and successfully try to go through each cell in the matrix. But that was just too much compute as well as just too chaotic of code, because by going through each cell and trying to assume a round world, there was just too many chaotic if-else statements going on in there and break statements, and I was trying to figure out whether break would cause the entire while loop to break, to which it does. So I could not follow that pattern. Instead, I set the iterators in the nested for loops not to the coordinate of each of these cells in this matrix. Rather, I set it to the supposed index correlating relative to the center cell that is a parameter whose location are parameters in that function. By doing so, I was able to also manipulate two declared integer values to account for a 3D world by taking modulo max of that value. And the other challenge I faced, which was the implementing the go function, figuring out how to just make this run 10 generations rather than infinite generations until this window is closed. To do so, I realized that instead of putting a for loop going up until 10 with a step call inside of it, I had to make an if statement and a separate outside integer generations remaining value. By putting an if statement rather than a for loop, I was able to run the step function only for that amount of times, generations remaining amount of times, because it was being decremented for each time step was happening, and the if statement only accounted for if generations was positive. So I realized the problem was putting a for loop inside of a while window dot is open, a function from SFML, would only run step, that call to the function, for each frame rate, for each one time, or the iterator amount of times for each frame. Now, realizing those things help me understand SFML much better, as well as understanding how to debug. And overall, this was a very fulfilling project. That is all I have. Thank you so much for listening, and thank you, Professor Barkeshli, for your amazing wisdom and teaching this winter intersession.